In the next four examples, we want to do the opposite of what we've just been doing. We want to take logs that are broken up over multiple terms and combine them into a single logarithmic statement. In example 2, we can start off by rewriting this as log base 6 of u squared, bringing that factor in front back up as an exponent. We'll apply the same approach to that second term to rewrite this as the log base 6 of v to the 6th power. Now what we have is the sum of two logarithms with the same base, meaning we can combine those into the log base 6 of u squared times v to the 6th power. In example 11, we don't have any factors in front to take care of, so we can simply combine this as the log base 7 of the square root of x over, since the original two terms were being subtracted, write this as over x to the 6th power, which would be the same thing as the log base 7 of x to the 1/2 minus 6, if we were to combine those exponents, or the log base 7 of x to the negative 11 over 2. From there we have a couple of different ways we could go about simplifying this down a little bit. We could bring that negative 11 halves out as a factor in front. Or we could just get rid of the negative exponent by writing this as the log base 7 of 1 over x to the 11 halves. So keeping in mind there are just a few different ways that we could rewrite or rearrange those final pieces to still have an equivalently correct answer. In example 12, we want to take the log base 4 of x squared minus 4 minus 6, which we'll actually just bring back up as an exponent. So we'll say minus the log base 4 of x plus 2. That would give us the log base 4 of x squared minus 4 all over x plus 2 to the 6th power. From here we can look at simplifying by factoring the expression in the numerator. Which will leave us with x plus 2 reducing with one of the x plus 2 factors in the denominator. So we'll get the log base 4 of x minus 2 all over x plus 2 to the 5th power. In example 13, we've got three terms to combine. The first two are being added together. So this would be the natural log of x over x minus 5 times x plus 5 over x. And that last term is being subtracted, so it would be all of that divided by x squared minus 25. X over x in the numerator would cancel, leaving us with the natural log of x plus 5 over x minus 5 times the reciprocal of that expression in the denominator. So if we have x squared minus 25 over 1, this would become 1 over x squared minus 25, or we could go ahead and factor that as x minus 5 times x plus 5. X plus 5 over x plus 5 will cancel, leaving us with the natural log of 1 over x minus 5 squared. Again, we have some options for how we could rewrite that. We could rewrite this as the natural log of x minus 5 to the negative 2nd power. Or we could bring that negative 2 out in front to rewrite this as negative 2 times the natural log of x minus 5. But again, equivalent expressions, just slightly rewritten using some of those properties of logs. The main key for each of these is to be able to take each of these expressions where we have logs split up across multiple terms and reduce them down to a log statement where there's only a single log expression.